Okay, let's do Cramer's rule for three equations with three variables. So here's an example. And remember, when we do these, I'll make them work out evenly. So you can check yourself a little bit that when you do this, you should get an even, a whole number, usually between -5 and +5. So step one, we're going to take just the coefficients and we're going to make it into a matrix. So it's going to be 2, 2, 3. This is the x column coefficients. 2, -2, 3, y column coefficients, and -3, -1, +2. That's the z column coefficients. So the very first thing you do is just use the coefficients. We don't use the constants over here, just the coefficients. Without the variables, you write them in order like that. And of course, you have to set the equations up. So all the x variables, all the x coefficients are in a row or in a column. All the y are in a column, all the z are in a column. And then the numbers are on the other side. Remember, these are three planes in three-dimensional space, and we're going to see where they run into each other, where they intersect. So that's what we're looking for. The x, the y, and the z coordinate, where these three planes intersect in three-dimensional space. Okay, so you write down the coefficients. Now, this is very important, and this only works for 3x3s, but you can do it with this. You repeat the first column in the fourth column. So right over here, I write 2, 2, 3 over again. So this first column gets repeated. Then we repeat the second column. 2, -2, 3. So we end up with 3 rows and 5 columns where the first two have been repeated. Now we're going to do down diagonals minus up diagonals. So we multiply along the down diagonals. So that's going to be -8. Multiply along the next down diagonal. That's going to be -6. Multiply along the third down diagonal, and that is going to be -18. We add those numbers up and put it right here. So -8, 6, -14, and -18 is -32, I think. And we're going to subtract the up diagonals. So minus, put a parentheses. Okay, now we're going to do the same thing, up diagonals, starting over here in the lower left corner. And that is going to be +18, I think. Go slow here, because if you make the least tiny little mistake, it messes the whole thing up. Next is going to be -6. Then we have a +8. Add those numbers up. Let's see, that's 12, and 8 is going to be 20. So over here, it's going to be -32, take away 20, take away +20. So that's going to be -52. Okay, and that's going to be the d. So when we solve our x and our y and a z, the -52 always goes on the bottom. So this first d, this is called the determinant of the coefficient matrix, and it is going to be the denominator of all our answers. So x, y, and z are going to be, all of them are going to be over -52 over d. So remember, x, y, and z are equal to dx over d, dy over d, and dz over d. And we have to figure out what the dx, the dy, and the dz are. Okay, so we know what the determinant d is on the denominator. We just have to find the numerators now, and then we'll know x, y, and z. Okay, so here's the tricky part. Let's do dx. To find dx, we take that same coefficient matrix, but we replace the x column with the constants. So I'm going to put in the first column, the x column, I'm going to put 9, 3, and 7. And you got to put it exactly in the x column. You can't put it in the y or the z column. If you're solving for dx, you've got to replace the x column. You can't switch the order of the columns. The first is always the x, the second is always the y, the third is always the z. Same order as your original matrix up here. Okay, the rest of the coefficient matrix is the same. So 2, -2, 3, -3, -1, and 2. So that's the y coefficients and the z coefficients. They just stay exactly the same in the y column and in the z column. Now we do the same thing we did up here. We repeat that first column. So 9, 3, and 7 becomes the fourth column, and 2, -2, and 3 becomes the fifth column. And again, we do down diagonals minus up diagonals. So that's going to be -36. This is going to be -14. This is going to be -27. Gee, what is that? I'm going to use a calculator for that. So 36 and 14 and 27. It's going to be -77. And we're going to subtract the up diagonal. So put minus parentheses. You got to be very careful with the signs here. So, write it down. That way you won't forget it. Up diagonals, this is going to be 35 positive. This is going to be -27. And then the next up diagonal is going to be 12, positive 12. So 35 and -27 is 8, and 12 is 20 again on top. So it's going to be -77, take away 20, that's -97, I think. Okay. Now, as soon as we get dx, we can put it in up here. Negative, and it looks to me like it doesn't work out. So I made a mistake somewhere there, I think. So -97 divided by -52 is going to come out to be a whole number. It doesn't have to, but I made all these problems, so it will come out to be a whole number. So let me check here, see if I can find where I made a mistake. So let me go through this kind of quickly. And you're going to do this frequently, often. Can't tell you how many mistakes I've made doing it. So don't get frustrated. Just be patient. Work on it carefully and see if you can figure out where the mistake is. Right there it is. Here's a mistake. So 6 times 2, 7 times 6 is 42. Positive 42, and I had 35. So I added a 2 and 3 instead of multiplying them. So that should be 42, take away 27. And that is 17 and 12. I think that's 29. Let me just check that. And I'll do it on the calculator just to be sure. 42 minus 27 plus 12 is going to be 27. And 27, 77, -77, take away 27 is going to be 104, -104, right? So it's going to be x is going to equal -104. So this is 104 is dx, and -52 is d. So x is always going to equal dx over d, which is going to be -104 divided by -52. So that turns out to be negative or positive 2, right? So x is positive 2. And it'll always be a whole number. I'll make it come out to be a whole number. So now we know x. Let's go down and figure out what y is. And you could do z if you wanted. You don't have to do it in this order. You could do z and then x, or y and then z. You can do any order you want. I usually do dx then dy, but you don't have to. So we do the same thing, 2, 2, 3. So the first column now is going to be the x column. The second column, we're solving for dy, so the y column I'm going to replace with 9, 3, and 7. The rest of the matrix is going to be the same. So -3, -1, positive 2. Repeat the first column, so 2, 2, 3. Repeat the second column, so 9, 3, 7. And now we're going to find down diagonals minus up diagonals. So here we go again. So this is 12. This is negative 27. That is going to be 6 times 7. That's going to be negative 42. So 12, take away 27, minus 27, minus 42. It's going to be negative 57. Minus the up diagonal. Don't really need that, sorry. Negative 57 minus the up diagonals. So this is going to be negative 27, negative 14, positive 36. So negative 27 minus 14 plus 36. That's going to be negative 5. So I have negative 57 minus a negative 5. So this is why it's important to write down minus parentheses, and you put a negative in there, and you can see it's going to add. So negative 57 plus 5 is going to be negative 52. So that is going to be dy, and y is going to be dy divided by d, which is negative 52 divided by negative 52. So y is just going to be 1. So now we know x and y. And we could go and figure out what dz was and then figure out z. But a simpler way that makes more sense is once you know x and y, plug those two values back into one of the original equations and figure out z. So this equation, the second equation, looks kind of easy to do that with. So let's do that. I take the second equation, and I know x is positive 2, so it's going to be 2 times positive 2 minus 2, and y is 1 minus z equals 3. So this is 4, take away 2, that's going to be 2. And then I think I'll take the z over here and bring the 3 over here. So it becomes 2 minus 3 equals z. So z is going to equal negative 1. Okay? So we have 3 answers. You don't actually have to calculate dz because we figured out what z was directly. So don't, that doesn't equal dz, that equals z. So you don't even have to calculate dz in this case. Now, you do need to check it. So watch how quick and easy this check is. I'm going to go back to the first equation, and I'm going to go 2 times 2, because x is 2, plus 2 times y is 1, minus 3 times z, and z is negative 1. So I do that on my calculator, and I get 9. And that's a good check for the first equation. You do need to check it in all 3 equations. So every answer in all 3 equations, but it doesn't take long. I just scroll through on my calculator. So the second equation, the first coefficient is 2, and it's minus 2 now. So I go minus 2, minus 3. So I'm sorry, minus 1. So I change that 3 to a 1. When I do that, I get 3, which is what the second equation adds up to. Third equation, I change the first coefficient to a 3, the second coefficient to a plus 3, the third coefficient to a plus 2, and that equals 7. So I check all 3 equations in about 15 seconds. Doesn't take much at all. You have to do that on the test. You don't have to show me, but you have to check in all 3 equations. So if you make a tiny mistake anywhere in this massive amount of work and you don't catch it, you're only going to get half credit on that problem. You're not going to get much credit. All right, practice, practice, practice.